Okay, in the earlier slides regarding temperature, we established this particular relationship of thermodynamic temperature or absolute temperature, what the expression looks like, and we also made some comment about consistency of the definition of entropy in terms of KL and W, its consistency with second law of thermodynamics. In this particular slide, we will talk about the second law and consistency of definition of temperature, which the expression is shown here. Now, for a composite system of our consideration, we know that the number of complexions or the number of microstates can be related with for the whole system, whole composite system is actually product of the individual number of microstates of gamma 1, which is a function of average U1, average energy, internal energy of the system, of the subsystem, and gamma 2 is the number of microstates, which is a function of the average energy of the system number 2. Okay, so given this, this relationship automatically takes care of for the composite system of our consideration. For this, and then this automatically takes care of the extensive or additive nature of the entropy, because entropy is equals to KLN gamma, or in this case for subsystem 1 it is KLN gamma 1, and that is gamma KLN gamma 2, and so on. Now let us just try to see that what is for a spontaneous process of say energy exchange between these subsystem 1 and 2, what is the entropy change for a spontaneous change. We know the condition is that for a spontaneous process delta S should be greater than or equal to 0, and delta S in principle can be written as like this. Delta S is delta S1 delta E1 into del E1 plus del S2 del E2 del E2, and because as we said delta E1 delta E2 is equals to minus del E1 as we discussed in the previous slide, so this relationship automatically appears, this one automatically comes, and that if we now use the definition of temperature here, then the expression looks like delta is equals to 1 by T1 minus 1 by T2 into delta E1, and that for a spontaneous process for this isolated system, that is greater than 0. The inequality is true for the spontaneous process. At 0 equal to 0, that will refer to the equilibrium position situation. Now given this, we can see that if T1 is greater, T2 is greater than T1, that means if the compartment 2 is at higher temperature than T1, then to keep this one consistent, delta E1 has to be positive. Okay, because if T2 is greater, so 1 by T2 is smaller, so it is positive, and this has to be positive, and that becoming positive means energy has flown into compartment 1. So naturally that is consistent with the notion that energy flows from higher temperature to the lower temperature. Similarly, if your T2 is lesser than T1, or T1 is at a higher temperature than T2, automatically to keep this condition satisfied, delta E1 will be negative. That means energy will flow out from compartment 1 to compartment 2, so delta E1 will be negative. So this we can say while in thermal contact, energy flows spontaneously from a system at higher temperature to a system at lower temperature, and this is what is the Clausius statement of the second law of thermodynamics. So we can see that the definition of temperature which we have used here is actually consistent with the second law. And let me stop here as far as this video is concerned.